Hi there, Physics 152. This is the experiment video for the third practical, which is the Electricity and Magnetism Module 2, activities 1 through 6. So first of all, I want to start just by talking about what a wire is. And so I think I'm going to actually distinguish between a wire and a cable. So in this lab, you're going to be using a lot of wires. The definition of the word wire is a slender, string-like piece or filament of relatively rigid or flexible metal, usually circular in cross-section, manufactured in a great variety of diameters and metals depending on its application. So this is a wire. Whereas a cable is an insulated electrical conductor or a combination of electrical conductors insulated from one another. And I just want to impress upon you that most of the things you call wires are actually cables. And so like this coffee grinder, the plug here, if you look, you can actually kind of see that it is two wires that are separated from each other by plastic. And and that's important because, well, because it connects here, but anytime you want electrical current to flow, you have to have a circle. And it's also going to be true for just about any cable you have. So even this plug for the computer, it actually has at least two metal strands insulated from one another inside this cable. So that's important. In today's lab, you're going to be using wires that are actually just single wires that have these what are called banana plugs on the end of them. So, and there's two kinds. There's red and there's black. Okay, and activity 1 is basically just taking your battery. So you've got a 6-volt battery with banana plugs on the top. So it's good probably not to damage this or drop it, but it's rechargeable. It has a little breaker switch on it in case you short it out. You have to press this again. And you have a little box with light bulbs. And so there's actually 3 light bulbs. They think they're all the same, 6 volts, 6 watt light bulbs, and they also plug into banana. So your first task will be to try to make one of these bulbs go on using a simple circuit. So, and now obviously electrons don't care what color the wire is that they're going through, but historically the tradition is that you take the red wire and plug it into the plus, which is held at around plus 6 volts, and then you plug it into one of these bulbs, and then the black wire you plug in the other side and pop it in the 0 volts, the ground for this battery. And what I do, I know this might seem a little, I don't know, a little silly or something, but when I hook up a circuit like this, I try to trace with my finger where the current is actually going. So it starts at the plus and it goes around through here, through the bulb, and then through the black wire, and back to the black, and then through the battery, and around. And so I know I've got a circuit there. Okay, next piece of apparatus, that you need, just put this over here for a sec, is called the clamp meter. And so this is a device for measuring current. It uses magnetic fields, but basically, you open the jaws by pressing this button and go around a wire. So I have to turn it on here. I'm going to put it on the 40 amp. So there's 2 settings. There's the 40 amp setting and the 400 amp setting, depending on how much current you're going to measure. So I tend to start it at the 40 amp, and if it goes over that, then I would turn it up. But then what happens, so again, the current is going away from plus. You put it through, or you can, if you don't want to disconnect your circuit, you can clamp it. You put it through from back to front, and you press the 0 button to 0 it, and it should show you the amount of current going through there. So when I plug it in, it starts at 0, put it in, then I can see, actually looks like about 1 point something. So the amount of current is going to depend, I guess, on the resistance of the bulb, and the bulb actually tends to change its resistance based on its temperature, so keep that in mind. It should go back to 0 when you unplug it, right? So it doesn't, and so it's good to do this a couple of times. Now I'm getting something more like 1 ampere, or 0.98. Then another trick, just in case you want to get a better measurement, you can actually put the wire through twice. If you go around like that, and double the amount of current going through it. So again, 0, you get 2 amps. Or if you go 3 times through, and then you can divide by the number of loops that you have through there. So that's a handy little trick for increasing your accuracy. There you go, 3 amps, okay. Okay, so that's called clamp meter. Okay, activity 2 is, I think, drawing just a circuit diagram. Activity 3, they tell you you've got a supplied unmounted flashlight bulb, which is right here in the little package, just a little bulb, and it says you take the battery and only 1 wire. And the challenge is, with just 1 wire, can you make this little bulb turn on with the battery? And so I think there is a way, but and if not, just let us know. Okay, activity 4 is about switches. So here is actually something that looks probably familiar to you. It's a light switch, but it has banana plugs on it. And there's another switch which is in your box, which is called a knife switch. So you can actually see the metal there and connect it. I think your first goal is to just try to hook up the light bulb and the battery using. You could start with just the knife switch. So you're going to need wires, of course. And again, it's up to you, but what I like to do is I always like to start from the plus, put a red wire there, and then connect it around. I think the first thing I'm going to connect it to will be the knife switch. So in there. I think I might as well get another red wire, just because I'm still kind of on the positive side of this thingy. Plug it into the other side of the switch. Let's open it up to start with, and then put it through a bulb. And then down the other side, as well, grab the black wire and ground that baby out back to the battery. And now if I close this switch, hopefully I should, so I see it there. If I close it, the light goes on. Okay. And then the other thing I can do is try it with the normal light switch and see how that goes. I'm putting 2 reds there, but you got it. Okay, so that works. And then the next thing is that since you have these 2 switches, you could try wiring the 2 switches in parallel with 1 bulb. And so idea being, you start with the plus and you split it. And so the way you can split these things and create a junction is, I don't know if you can sort of see it here, but in the side of the banana cable, you can actually plug another banana cable. And this creates a little junction. So I'm going to wire this red into one of the switches, the knife switch, and then the other one also connected into the other switch. So we have 2 switches, the plus, and then so the current can go through now either this side or that side. And then let's also take red, I guess. I'm running out of wires here. Maybe just so it's not so confusing, I'll start using black. So the black from this one, and the black from this one. I guess I'm going to connect again to each other. So I'm going to take these blacks and put them together, so that now the switches are connected in parallel. And now this can go through light, and then also have to ground it out here. So I've got two switches now wired in parallel, and you're going to have to, so now when you go through, you have to have two things. You have a junction. So this looks like a big pile of spaghetti. It starts to get a little complicated looking, but just keep in mind when there's a junction, the electricity can now split going one way or the other. So now you got to see if you can, what does it take to turn on this bulb, and what are the different ways that you can wire these switches. Okay, that's activity 4. Okay, so for activities 5, 6, and also 7, the new piece of apparatus that you need is called a multimeter. So here is a multimeter. It's battery powered. Actually, you have two. I think you use the second one in activity 7 if you have time activity. But so basically, it's got this dial. It's got a lot of different functions on the multimeter, but first you're going to be using it as an ammeter. So you find the A on this circle, and in fact I think there's two. There's A with a wiggly line on top. That stands for I guess the alternating current, and then the A with just a line with a little dash underneath it, that's stands for DC. So I'm going to put it on the 300 milliamp. I guess there's also the 40 milliamp, and I guess the 10 amp if you're going to use this. Basically what you're doing here is you're plugging two wires into, if I put it on 300 milliamps here. Wait, so I plugged the red wire into to yellow because I'm measuring milliamps there, and then the black wire I plug into the ground, which is called COM. And so now, if I'm going to use this as a multimeter, I have to have a circuit, and I plug it into series with the circuit. So the circuit you're going to be using is that one you did from the very beginning, which is just a simple circuit. So I've got the 6-volt battery here. The plus goes to one end of this light bulb. The black wire goes back to ground. It turns on the bulb. So if I want to measure the amps going through this, not using, I guess I could just use the clamp meter, but another way of doing it is what you do is you break the circuit, and now, actually I don't need this, you use the ammeter, you plug the positive side, which is I guess coming out of this bulb now, into this milliamp, and then the ground, you ground through. So what you're doing is you're hooking the ammeter in series with the circuit, and then ground it out through the ammeter. Whoa, I didn't like that. I think it's more than 300 milliamps, so let's put it on let's actually put it on the 10 amp setting. So instead of going through a milliamp, I'm going to put through what's called the 10 amp, and then put it on the 10A. So that will allow up to 10 amps of current. So if you're going more than 40 milliamps, which I think you are, that's what you have to use. There you go. So now I've got it says 0.90 is the amps there. So that's a good measurement of what's going through this whole circuit. So that's ammeter mode, and you can compare it, I guess, with what the clamp meter reads. So hooking up the circuit again, the next thing that you can do is you can use the multimeter, this, in volt settings. So, and again, volts has the volts with the wiggly line over it, or the volts with the solid line and the dash line. You want the solid dash line, the DC volts, and it's a 6 amp thing. So you can have maximum 4. That's not going to be enough because we got a 6-volt thingy. Let's put it on maximum 40. And again, the black is COM. And now you're going to use the red socket on the other side for V. So this is the thing about voltmeter. For voltmeter, you don't put it in series with the circuit. You put it in parallel. So I'm going to just have the voltmeter sitting there. So, and I can just plug it right in, I guess, across the battery and get, oh, a little different there. When I plug it right in, 6.38 volts on my voltmeter. So that's just in parallel. You don't want to do that for the ammeter setting, but with the voltmeter, you can put it in parallel. Okay, so then when we've got the actual bulb lit up, you can measure what's the voltage drop across the bulb by just putting it in there. Ooh, 5.11. That's a little different, which is kind of interesting, than the voltage that's across the battery itself. Oh no. Oh yeah. So it's a little larger. So I think probably there must be voltage drops in the wires themselves. So that's something that you can investigate using voltmeter. And then I think activity 7 is you'll hook up the ammeter in series with the circuit, so you always know what the current is, and then use the voltmeter, so one multimeter in ammeter setting, and what you can do, like put it on a 10 amp, and keep that in series, and then use the other multimeter in voltmeter setting, and measure the voltage at different points in the circuit. And so that's it for your circuit activities this week. Have fun. I hope as a lead experimentalist you get a chance to plug this stuff in and be like the circuits expert. So, okay, take care, have fun, bye.